Welcome to our third FRC Java tutorial. In this video, we're going to pick up where we left off and create a drive command so that we can get our robot moving. As we make the command, I'll be talking you through the dynamics of commands that are applicable to all commands. As always, the code we created today will be on First Robotics Canada's GitHub page. The link to that and more resources will be in the description box below. To start, we're going to make a method that returns a joystick in our operator interface, or OI class, so that we can use a joystick for our drive command. Then we'll be going into the command and how to set it up. Let's open our OI class. Here, I made a joystick object and named it driver stick. This way, it's clear which stick belongs to the driver and which would belong to the operator. The driver joystick is in port 0. You can check what port that is on your driver station, and you can change the port manually there as well. Then, I made a method that returns the joystick, so we can use our joystick using the available methods in the FRC Java API. Now, we're going to make an object in our robot class for our drive subsystem to access our drive subsystem's methods. We don't have to put the object there, but as you can see with this example, it's recommended we make an object for each subsystem for organizational purposes. Now, onto the command. Last video, we set up our method that will allow us to drive our robot using a joystick, so let's put that to use. If you recall, subsystems is where we set up a mechanism's capacity to move, and commands is where this movement is actually executed. We're going to make a new command for this, and I'm going to call mine drive command. In initialize, which if you'll recall, is called only once at the beginning of the command, we'll be using our stop method, which stops the motors of the drive to ensure that our motors aren't moving because of another command. Doing this makes sure our motors will not be receiving conflicting speed values, which would cause the drive to jitter. Then in execute, which runs repeatedly, executing the command within the method several times a second, we are calling the drive method that we created. Here is where we define that we are using our driver joystick, accessing it from our OI class and the predefined OI object in our robot class. Then I set the speed multiplier to 1, which means the values sent to the motors by the joystick will not be dampened at all. In isFinished, the method returns false. This means that it will not end the command unless the command is manually cancelled, where the isFinished condition is overridden to end the command. In our end command, however, we make sure to stop the motors, and just in case anything interrupts the motors as we're driving, it immediately ends the command here. Now let's actually get our command to execute. We're going to go into our robot class again and make an object for our drive command. The first part of our command is actually just command and not drive command, because commands we make are actually extensions of the command class. We are simply using the command skeleton for our own usage. I named my object drive command to keep things crystal clear. Now we're going to scroll to teleop init. Remember, teleop init runs a single time at the beginning of teleop, when we can start using our joysticks. This is the easiest part. All we're going to do is start our command right at the beginning. This gets the command running, and since there's no isFinished condition, the command runs unless it's interrupted or cancelled. If you have another command that you execute that interrupts your drive command, be sure to start the drive command like we did here in your end method in your command so that you can drive once the command is done executing. That's all for this video. In our next video, we're going to be discussing autonomous, where we'll go into more detail about isFinished conditions using a timeout. See you next time.